Okay, a couple announcement. So I already put the midterm exam on Canvas. So it'll be next midterm exam will be next Wednesday during the late time. And so I understand some of you will still be traveling, not returning to class on Wednesday. That's fine. You can take it somewhere else. So I'll be out of town this Thursday and Friday, so we don't have class here on Friday. So basically, you can start having the holiday, the fall break Thursday until next Friday. Okay, so I will see you again next. Oh, I will still be here on Wednesday, right? Yeah. So Wednesday, and then I will see you next Friday. Okay, so we will not have class this Friday or next Wednesday. So the quiz you can take it anywhere you like. Within during the lab section, 1 hour, 3 questions, open book. By must your independent work. Okay, so don't try to communicate with others. You can use ChatGPT, whatever you like. So should not be too difficult. 3 questions, one 50 minutes, but I open it up I think on 9 a.m. so you can take it 10 minutes early if you want to, but it's basically within 1 hour. And yeah, you can take home if you like to come here, fine, you can do it here if you want to. And there will be no assignments this week. So lab 5 is due this Friday, Thursday, right? Thursday, and then so you can enjoy your break. Okay, but do prepare for the midterm. If you cannot make it during the Wednesday, if you're traveling somewhere in the remote area, no internet, fine, just let me know. You can take it after you return. Okay, makes sense. So enjoy your fall break, maybe a week, and then you can come back. But I will see you next Friday and I'm back. So I will be Thursday, Friday at where? University of Colorado, Denver, and then next will be at Google for the Geospatial conference. So I don't have a break. I like traveling. Okay, and so for the midterm, pretty much cover I think what we're going to do this today and also Wednesday, some analysis, but 2 questions from the previous one more question from this week, and so it'll be only 3 questions, just like the very similar to the quiz that we have in class. Submit a screenshot, submit the link to your notebook, that's it. If you have any questions, any concerns, let me know. And we're still right on schedule. If you see here, analyzing geospatial data. So this week what we're going to cover. We still have a little bit, excuse me, from the last week, visualizing geospatial data. There are 2 more things I want to talk about in class today. And so here, if I scroll down, these two, time series inspector, and also excuse me, and time series inspector and time slider. So these two are quite useful. It's particularly useful if you want to visualize a lot of images. So think about you have in remote sensing, most likely sometimes you have to deal with time series data. Okay, and if you have many data layers, it's not very convenient that you add all the data layers to the map, because if you're going to turn it on and off, it's not very convenient. So this example here shows you, for example, I'm going to use the NLCD lane cover, right? So NLCD lane cover, I'm going to select the lane cover band. So national lane cover database is 1, 2, 3, 4, 8. Actually, we already also have 2021, but it's not included in this one here. So think about you have 8 time periods for the entire US. If you want to visualize all of them, you have to add all the 8 data layers individually to the map, right? So you're gonna have 8 data layers. It's not very useful. What you can do is use this one called TS inspector. So time series inspector. Let me run this one just to show you what it looks like. So pretty simple and easy, right? On the left side here, you can have a drop down list. On the right side, you can have the drop down list. So basically allows you to compare 2 data layers side by side and you can like drag left and right, so allows you to compare data layers with rather than having 8 data layers and then turn the data layer on and off. Maybe let me zoom in here a little bit here. Like I said, it used to be you can drag the map, but now because there's a bug in IPyLeaflet, so it doesn't allow you, but that's fine, right? So here, so on the left side is 2001, on the right is 2019. So if I change it, I can drop down this, I can select data layer and pay attention to the map on the left. You see it changed? So basically select whatever data layer you want, right? I'll go maybe 2016. Right. So in this way, you can visualize as many data layers as you want without having to add all the data layers to the map. So here, what we're doing is create a map, and then this is an image collection, and then you select the length cover band. There's a function here called aggregate array. Aggregate array means kind of like, think about you have a spreadsheet table or a swap file. Aggregate array is aggregate column. So you have a column name and you get all the values. So that's called aggregate array. But if you are kind of confused, you can take a look at the first one. So what you can do is, for example, collection. So first, so you can just look at the first image and look at the property. So here, the property is whatever the property here, although it doesn't mean much, but what we're taking is essentially this one. So think about a spreadsheet with different columns, and there is a column called system index, right? So it can be 2001, 2004. So aggregate array is grab that column, all the value, because each image has a property. Kind of like in here, right? In this whole class, I store your information in a spreadsheet, right? And you have your name, you have your major, you have your address or something like that. I grab the entire column so that I can get all the information all at once without having to loop through. So aggregate array is a very useful function. They also aggregate min, max. Basically, if you want to find some information out of that, you can do that. So I recommend, if you want, you can go to the help documentation just to quickly show you. If you want to get some summary statistics, this might be useful. So it can apply to a feature collection and also image collection. So they come here and either image collection. So take a look at this one here. Aggregate array, aggregate account, aggregate first, min, max, product, statistics, something like that. So this can be useful if you want to get something out of the column. So for example here, you can simply do this one. I can do aggregate array, and here, right, I know the first one, but aggregate array and then maybe aggregate count, right? So if you want to see how many values in there, right? So it's aggregate count, see 8, right? So I can know how many in there. I can also aggregate min and max, right? So for example, max 2019, 2001, right? So aggregate array is useful. I can also do aggregate stats. Oops. Can reduce. Oh, it can only apply to number because this is a string, so it doesn't allow you. But if you have population or have something else, you can probably do that. So like I said, if you don't know what column in there, you just print out the first value, print out the first item, and then you should be able to see what attribute available. So here, let's just print out first again, and look at the attribute. So the property, everything here, these are where you can do the statistics. There's a time start and time end. You can, this is basically the second, the number of seconds starting from 1970, January 1st. So the number looks like very weird, but if you want, you can reformat it. Let me remove this one. I will show more example later using, for example, feature collection. But for now, think about this is an image collection. So we can use this function, TS inspector, to visualize any time series. So all we need is just passing this time series, and then the left TS is the one you want to use the left, right? So it'll be this drop down list, and on the right you can do it using the same, but you can also use a different collection if you want. And the names, left names is the label, so it's what we're going to use in the drop down list. So it's the number of years is coming from here. So basically, this is the list of labels on the right. So basically, everything pretty much the same. And then the visualization is how you're going to visualize. It's kind of the same as you do it in here, right? I'm just going to pull out the length cover band and then do it. And then the width is like the width of this drop down list. So if it is too wide, you can change it to a smaller one. For example, 60 pixels. So it'll be narrower, right? So right now you see this, it's smaller. If you want to be bigger, like 120, for example, you make it double. So this one, the label depends on how the width of your character. So for example, this is like 2001. You can like maybe year 2001, year 2019, right? So if you really want to write, I can, let me see, do it here, right? Collection years, and I can easily do this way. So I can do years equal to, how do I do that? Do this, list, and then you'll be year, okay? Class, and year, oh no, I think it's colon. Colon? I forgot it. For year in years. I'm not sure if it works. It's, wow, it's, or I can do it this way. Either one is fine. For year. So what I'm trying to do is to convert it to 2001, year 2001, year 24. There should be a lambda function. I forgot what exactly what it's doing. For I, let's see. Oh, I will need the new one. Okay. New years equal to like this. And then for year in years, right? New year to append. Okay. Then I can just do year plus year. Okay. And then new years, right? Like, just like this. You need a space. And you need space here. Like this. Right? And then you can pass this one into your list, like in here. Maybe new years, new. It's just an example, but you can do whatever you want. I'm just saying, if you want to change the label, you can control it, and then, but the number of years need to be the same number of images in the collection. Otherwise, you're gonna throw an error. So here you can just customize, and then maybe you change it to be a little bit shorter, right? 100, just to be more specific. Right, and then you can zoom in, you can zoom out pretty easily. So this is how we can visualize using the drop-down list. There's also another way. So this one is called time slider. It also can be useful to visualize longer time series. In this example, using the temperature data, the MODIS data, and then select the NDVI, the normalized difference vegetation index. And this is how we're going to visualize that minimum, maximum, and also the palette. So the function we're calling here is called time slider. And then in there, you passing the image collection, how you want to visualize that. You can also specify a reason. Then the last one is the time interval. The time interval is when you are playing the time slider, how fast you want it to be. So look at this one. This is the Maldives data from June 1st to July 1st. And it has imagery one daily, basically. So in here, we have 30 images from June 1st, June 2nd, all the way to uh, June 30, right? Yeah. Yeah. So we have 30 days. So what we are doing here is has this time slider, and then I can just drag this through. Take a look at this. And again, you have 30 data layers. You of course you can add 30 data layers all to the map. It's going to be overwhelming, but this is better. So this is actually only one data layer, and you can probably see the changes of the vegetation. Any changes? It's just one within months. It might be hard to see. You need to pay close attention. So here the vegetation, and so let me move on to the end a little bit, right? So not very obvious, but you're doing like longer time series, it might be easier. So this is what it's about. So if I click the play button, it's just going to go through all the data layers one by one, and you can pause it. Okay, pause this time slider, then it's going to stop. Again, you can drag it left and right. So this also can help you visualize the time series without having to add all the data layers to the map. Otherwise, it's going to be overwhelming because you're going to have all the data layers in here. And so the image, oops, is basically here, and the time series. So this is basically the original image collection. There's no visualization or anything, just adding the original image collection. So what this one is changing is the image X. So every time if I change the slider, it's going to replace the image with the new one. Okay, and you can also do, for example, weather and climate data. So this one is using the NOAA temperature data, and this one is within 1 day, 24 hours, right? So every hour you have one imagery. So look at this one here. Again, also the temporal resolution depends on the imagery. Some might have daily, some might have hourly, or might weekly or yearly. You need to look at the metadata information on the Earth engine documentation. And so in here, we are basically just, okay, we want the within 1 day, and limit 24, basically you only get 24 images. Then select the temperature band. Again, if you are unsure, you can just copy this one and then paste into Google. In here, it's going to show you global forecast system. And if you scroll down, it's going to tell you like what band available. So we are actually using this one here, list data. And you can look at the sample code here, see how to use that, right? So this is using just 1 day, and then select the temperature band. Automatically it's 24, but sometimes if it's more than that, you can limit just to 24. And then this is how I'm going to visualize that. Lastly, there's a label. Okay, well, let me talk about this later, but pay attention to this one, right? Add time slider. So similar to the example we saw earlier, give the image collection. So it doesn't matter how many images you have. So this one is 24, right? 24 images, and this is how we want to visualize each images. Then passing the label. So the label is where it's going to show up here. Right now it's 0, 0, 0, 0, right? So if I change it, you're going to see 10, right? So 24 hours UTC. So 17 all the way to 23. Then go back to 0 and 1. 0, 0, right? Can you see any changes throughout the day? You're going to pay attention to the red color in here. So during the day, it's probably going to the temperature is going to way higher, right? In Africa. Okay. So this shows you how to pull any data. Again, you can visualize any image collection. So what this one is doing here, this is the hour. So let me go back to this one, the label, right? And okay, so this is the one it's doing here. So for n in range 0 to 24, so basically 0, 1, 2, 3, all the way to 23. And for each one, we're going to do it like this. So we're going to get the number, and then G fill basically is to fill in the number, convert it to string, and then have 2 digits. And then colon 0, 0, something like this. So that's why it becomes 0140000. So this number 4, and then convert to a string, and then it needs to have 2 digits. So it basically fill in the 0 in here, 04. So basically just to standardize. If you have never used this function before, I can quickly show you an example here, right? So for example, you'll be what's that? So str, for example, they say the number 4, right? You can convert it to a string, and then you can also do the g fill, right? Like this. Kind of like in Excel, sometimes you have to format the column, and so that all the column have the same number of digits. Then you can do this way. For example, you can also do maybe 4, right? Or you can have like, for example, 99, right? Oh no, no 99. Yeah, of course you can do 99, right? Whatever number you do, it's gonna fill the number. So in this way, it's standardized. So then, okay, like this, colon 00. If you want to do it like this, you can certainly do it. So this is where it's going to format the label so that eventually you have a nice time slider with the same format of time. Make sense? So you can try it with any data you like. For example, here I can also do Sentinel images. So what this one is doing is create a map. This is the entire Sentinel image collection. I'm going to filter at this coordinates, latitude, longitude, and then I'm going to select all the cloud images, percentage less than 10%. So usually it's pretty good images. And this is how I'm going to visualize each image. So I'm going to select B4, 843, force color composite, and select this. And so if you don't know how many images you have, you can easily do this way. So what you need is just collection. What? Dot size. Right? So see how many images? Like 97 images. So we have 97 images. All we need is just add this, for example, just one line of code. It's going to visualize these 97 images, right? And then it is. It might be hard to tell the differences because this is the same location. Oh, what's this? It might be just all kind of is it the ships or here? Might be. No, hopefully it's not the sensor. Not the ships, I see. Sometimes maybe it's the same the sensor, the artifacts. This is too much. It's not. Yeah, this one looks fine. But like I said, you see, you can filter the images for any location and you can quickly visualize, right? So I'm just doing the intersecting these images. So all the Sentinel-2 images are being retrieved and then you can easily visualize. So this is 97 images, right? From all the way from the beginning to now. The latest one was September 21st, right? Only a week ago. So if you want to see any images, you want to see the time series, this is probably the easiest way. Just filter and then just get that. So here, for example, right now, if I'm asking you in the quiz, okay, visualize the time series images covering UT. How do I do that? What do you need? The geometry. Yeah. So how to get the geometry? Yeah, you can draw a polygon, you can draw a point. So for example here, let's do it from here. How is it? Right. So around UT here, fine. I can maybe just let me see if it works. Usually I will use this one, but it's a bug, so it might be jumping. Okay, it's jumping. But anyway, I think it's pretty close. So I'm just going to copy this one, come back here, and then replace this one. Next, remove this one. And then do the same thing here. Copy this. Move this. Anything else we need to change? Say it again. Yeah, I already changed it, right? Latitude, longitude. Oh, this one is reverse. Okay, good catch. Otherwise, you're gonna get weird result. Uh, so for Google changing, it's longitude, latitude. For I leave that it's latitude, longitude. I just use different convention. So, but see how nice. How many images we have? 150. Okay, a whole lot more. So basically means we have better, more images. And now if you see here, right? This is 10-meter resolution. So if you need some high resolution, I think was somewhere here, maybe this building here. It's a little bit difficult to see. So this is 2018. Maybe look at the what's the student unit? It's somewhere here. Is it this? Is it somewhere here? See if we can see the changes. Okay, this is what it has right now. Yeah, the resolution is not high enough, but it's supposed to be something like this. But at least, right? So if you want to do like a large area, not at the building level, this might be good enough. For example, you want to extract the water, vegetation, right? So you have 150 images visualized all at once without having to like go online to download. So you can get any images you like, and then just quickly navigate through to see how it changes throughout the season, throughout the year. And if you click the button, you can do that, but it's not very smooth because think about it's actually retrieving the data layer, and there's going to be some time lag from Google Sensing. So you're going to get the data layer from Google Sensing and then coming back and then replace. So it's not like very smooth. You need to wait some time, but at least you can see some changes, right? For example, the lake, the what's this? The Tennessee River, right? You can see the color changes. Certainly during the summer year, right now it's pretty dark, but there's some like you see the kind of the green color. That means there's something in the water. And this one is very clean. Like, sometimes you will see some greenish, so sometimes might be some the water quality basically changes throughout the year. It's not always going to be the same. So if you are starting like longer time series changes, this can be very useful. So now you can basically pull out any images for anywhere, for any location, for any time period. Right? Look at this, like, what is this, right? What happened? Because without this, it's hard to tell. But now you have a big picture, you can see what is going on over there. Okay, so this tool, the time series inspector, is basically the drop down list. The time slider basically at the lower right and allow you to slide through any time period. So now you can basically go online just to filter any image collection you like by any location, by any attribute, and then figure out how you want to visualize that. Then just use the add time slider. That's it. Okay, so next, yeah, we're done with this one. You're welcome to go through others. So those are not critical one they're going to use in this course. So I'm going to go through to the chapter 6 about data analysis. So data analysis is important because so far we have been querying the data, visualizing the data, but we haven't really done any analysis yet. Okay, so it's very common if you're doing with Google Sensing or any geospatial. From time to time, you have to do some analysis, not just for looking at the data. It's nice to be able to visualize, but you want to answer some questions using the analysis capability. So Google Sensing is very powerful, makes it really fast to do analysis, and you can do it at a global scale. So maybe just a simple question, right? I can ask you, for example, in the US, which US state has the lowest mean elevation? You know, how do you calculate it? Which one? Florida? Anyone else? Louisiana? We can find it out. Okay. Once you finish this chapter, you will know. It's not Louisiana. It's not Florida. Or which US state has the highest mean elevation? Colorado. Yeah, Colorado. And how do you figure out that? How do you actually calculate it, right? So think about it. What data do you need? DM, right? Besides DM, what else do you need? State filter, right? But how do you calculate all the states all at once? You want to calculate one by one? Or you want to calculate all at once? All at once, right? This is where the power comes in. Let me see if I have the answer here. Yeah, this one. Take a look at this. This is what I'm going to show you. I'm going to directly go into this one so that you see what we're trying to do here. Why statistics or the analysis is very powerful. So look at this one. We have the the DM, and we also have the US state boundary, right? So by visually looking at this, right, highest mean elevation is pretty easy to identify, right? Somewhere here, right? Colorado, like Jack mentioned Colorado. But which one is the lowest elevation? Lowest mean elevation, like if you take all the pixels within a state and then try to calculate the mean. So which one? Anyone to guess? Delaware? Yeah, let's find out. So here, right? Pretty simple. We get a DM. How we want to visualize that. There's also the what's this? The length here. We don't have to worry about it right now. But we have the state boundary, and this is how we visualize state. So next, let's figure out how you calculate the statistics of the DM. So what you need to do is actually just one function here, just one function. We can get the result. So gmap.zonal stats, and then within here, shift tab, you can pass in a raster and also a vector, and save the result output to a file. So what we're doing here, by give me a DM, give me a US state feature collection. Output, output is a CSV, and the statistical type is mean. So mean means we have the feature collection, like every state. Within every state, we're gonna calculate the mean elevation, right? The DM and the scale. You can specify how you want to calculate. But if you're doing that for a large area, you want to have choose a larger scale, because the larger the number, the smaller the number of pixels. Originally, this DM, for example, is 90 meter. You can choose 90 meter, but in my memory, it might be exceeded. Then you won't be able to do that. Okay. So here, I'm setting 1000, and then return FC to false. So basically, if you want to, you can either save it as a CSV, or you can return the result as a feature collection, and then you can use that to follow computation. But for now, I'm just saying, give me a DM, give me a zonal polygon, and then I'm going to calculate whatever statistical type that you specify. And take a look. It's, see, all done. It's less than 2 seconds. Now I have this CSV, and if I open this one here, scroll down, EM states. See? So the mean column, and it also has saved all the values. So if I scroll to the right, you should be able to see the name of the states, right? Here, the name, and which one has the lowest? No, it's not. This is not ranked alphabetically. So you will have to open using Excel, or you can also do that here directly using Gmap. So let me come back to here just to show you what you can do. I'm gonna come here. I'm gonna use CSV to DF. Okay, and then I'm gonna passing this EM, the file name, out state, right? So now I have this, and we're gonna sort this column. So we can, I think, dot sort. Okay, what is? Yeah, there's no auto completion here, so it's a big anything. So you be maybe mean. Let me see if it works. Okay, nice. Okay, is it sorted? Right. So the lowest elevation will be this one, mean elevation. So what's that? Delaware. And what's this one? MP, like Maria Island or something. So look at this. Commonwealth of Maria Islands, and then Virgin Islands, Florida. I mean, within the U.S., it would be Delaware, Florida, Louisiana. So Louisiana is number 3, and then DC, Rhode Island. Oh, not DC. Is it DC? Yeah. District Columbia. Yeah, DC, Rhode Island. Right. So which one is the highest? Which are the top 3? Colorado, Wyoming, Utah. So if you go back to the map, it makes sense because you see somewhere in here, right? So these 3 cities. So how many lines of code take you to answer the question? 1 line. Of course, you need to add the data layer, but just think about this. Like, what other question can you answer? If I give you an image of, like, for example, temperature, temperature for a specific time, and I ask you, find out, for example, which state has the highest mean temperature at that time. Can you do that? How many lines of code? 1 line, right? Zonal state, and then you can just, you need to just pull out the data layer, then just call this function. And if you want to, for example, do the sorting, you can easily like sort the values and then by this mean column, and then you can find out which one has the highest or the lowest, right? So the elevation, this is just one doing one band, but I can also do multi-spectral bands. So this one here is doing the same thing. Give me a landscape imagery, and then the state boundary, and then I'm going to output, for example, also calculate the mean. I can do the same. Okay, so this one here give you the, is it done? The refresh, and then the length set. Right. So this one give you multiple columns, right? So B1, B2, B3, all the way to the end. And what this one is doing is that if you have an imagery that has multiple bands, for example, think about you have temperature time series. You can have multiple images within the same, multiple bands within the same imagery, and then you can calculate all the values. So this one give you a time, the spectral band, right? So basically the mean of B1 for a state, B2 for a state, right? Just like elevation, you can calculate multiple if you want to. So this is how you can do that. And let me show you one last thing that might be useful. So here, earlier we calculate this one and then we return the FC equal to false. We can also set to true to get the result, so that it the result keep in the cloud, because after you export to the CSV, right now the data is locally. But if you want the data to stay in the cloud, then you want to set this one to true. Let me show you what does this mean. So if you set to true, then you have to, for example, here, save it to a variable. Okay. So for example, FC equal to something, and let's run this one more time. Okay, it's done, but it's actually not calculated. It's not finished until you add the data layer or you request it. So here we can add this one back to the map. I can quickly show you here. Add map, add layer, and then FC. This will be here, and then we can say mean here EV. whatever. Okay. So I'm adding this one back to the map. Take a look at this. So now the data layer is on the map, and let me turn this one off. US state, right? See this one here? Now I can actually use the inspector to see. Right, so click here. You see the mean elevation, this feature, properties, and you should see the mean. You see the mean somewhere? It might be blocked. Let me full screen here. See this one? Yeah. Right, how about Texas? You can click the checkbox so that it's always expand, so that you don't have to click the checkbox anymore. I don't need this RTM. I need to click this one. Right. So in this way, you can see the values. And if you return to FC, basically return feature collection, so that the value will always stay there. Right. Compared to the original vector data that doesn't have this value. Now we have the value. You can easily. So if you want to stay the data to stay in the cloud, so that you can use to do volar analysis, you can do that. So let me show you the in here. Earlier we mentioned the aggregate array, right? So aggregate array is like the DM statistics in here, right? So this one right now is a number column. Or maybe do this. I think it's better to do this way. How about find another one? So A lane, right? For example, lane area, and I believe this is in square meter, right? Square meter. So you can use the aggregate array to calculate, for example, the total, the maximum, the minimum, the text, whatever you like, right? So here, right now, we have this column, A lane. So you can come back to here. We can just use FC dot, right? Aggregate array. So if you just FC aggregate array, you get all the numbers. Or I can calculate aggregate sum, for example, right? And then just do A lane. See, you get all the number quickly, and then you can divide it to a specific number. For example, here, this is square divided by 6, right? So it's what's that? Square kilometer. And then what's this number? 9159. I know it's hard to say, but I can just find out US state, US area in SQ square kilometer. It should be pretty close, like 9.834 million square kilometer. Oops. 9.8, is it 9.8? No, 9.1. So because it probably doesn't count the some of the other areas, but it should be pretty close, right? So it divided by 6, this 6, and then 3, right? So 9.1 million. Because this, the boundary is kind of a little bit simplified. So the area is not exactly the same, but I'm just showing you, if you want to calculate, for example, the minimum, the maximum, the sum statistics, you can do it easily using this. Right, so we can calculate all the statistics. And if you scroll down, it's going to show you the maximum, the mean, the minimum, standard deviation, total, weighted sum, blah, 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 blah. Right. So any column. So think about every, it's just like think about a shape file attribute table. You open the attribute table, and then you grab one column, you do some statistics. Okay, so it should be pretty simple. So this is how you do zonal statistics using a raster and also a vector. Okay, an image of feature collection. The next one here, I'm going to show you another one. Is zonal statistics by groups. So what this one is doing is kind of similar example to what we did earlier. So earlier we used the DM, right? And then we calculate the mean. But this one here, I will ask you a different question. Maybe, how about this? Which US state has the largest in terms of agricultural area, which one has the largest percentage compared to its state area? Which one has the largest agricultural, for example, agricultural area compared to its state? Like, for example, 20% of the state area is agriculture, or 30%, 40%, I don't know. I'm just saying, right? Basically, figure out in which US state agriculture is the dominant land cover type in next state. Which one? Which one is the agriculture? 82, right? This brown is area. But can you tell, like, easily from here? Alright, so this one right now, we are not calculating the mean, the maximum, the minimum. Because each state has multiple land cover types, right? You can have agriculture, water, all kind of stuff. So we want to calculate maybe the total area, or you can calculate the percentage, right? So again, it speaks just one line of code here. And this one is called zonal states by group. By group means you give me a vector, give me a raster. That raster, it has numerical values, different categories. And I'm going to show you, like, get the result. And here is calculated the sum. What this one is doing, like, for example, which US state has the largest agricultural area? Which US state has the largest forest area? Something like that, right? So again, just run this one. You can look at a couple seconds, and you should get the result. So you can calculate, for example, which one has the largest urban area, largest forest area, or wetlands, or water, whatever you want to calculate. And this one is a little bit more computation intensive because you need to calculate. Think about if a US state, right? Here we have a lot of categories, right? In total, we have over 20 categories. So we're going to calculate the statistics of all the categories. It's already done. And then here, I'm going to see the result. So it's the NLCD states, right? And look at this, class 81. So it's not by sequence, because when it's doing the calculation, it's kind of random. So 81, 71. So the value, the class underscore, the value is equal to the value of your raster. So basically the image has, look at this here, right? So the value is so at the beginning. You can certainly, for example, have half of my mouse. I click on the map here. It's going to show you the value of that specific land cover. So here, for example, land cover 82, right? 82 basically means here you need to find number 82. So what this one is doing, so this one calculates the total, the sum of all the pixels within each polygon, right? So now you can actually figure out which US state has the largest, for example, agricultural area. What we want is this one. So we can do the same thing, come here, right? Once you get the statistics, so now I have the CSV. So what you need to do is just gmap.csv to df, right? And then I can do what's this, NLCD state. So basically the CSV, and then doc sort values. So sort values, we're gonna sort by the column, right? So you'll be class 82. So this one is the agriculture, right? So let's see if it works. Take a look. 82. And right now I was sorting from the what's this? From the smallest to largest. We can actually do the reverse. I think it's called, it's descending, it's ascending. No, it's ascending. Ascending equal to false. So basically it means descending. So now take a look at this, right? 81. Okay. This is too much. So I'm just going to show the post 5 columns. We're out of time, but take a look. Which one? Surprise! Iowa. Okay. Iowa, Kansas, North Dakota, Illinois, Minnesota, right? So how easy it is, right? 194, you can do all kinds of statistics. So now, giving an image, giving you a vector, you can do all kinds of things you want. You can calculate population, for example, right? If you have a population raster, and then you want to calculate, for example, which county has the largest population or whatever. It can be land cover, it can be temperature, it can be slope, it can be anything, right? So most of the time we are just doing some analysis based on an image, and then based if the image is like continuous or is it like categorical image. For categorical, you use the zonal statistics by group. For numerical values like elevation or something else, you use the zonal statistics, not by group. And there are other types. We cover that on Wednesday. Okay, so make sure you practice. We might have a quiz on Wednesday, and then we'll see you next Friday.